Hey guys, we're gonna talk more about quadratic equations today and the parabolas that we've been kind of investigating, exploring throughout this unit. I just wanted to clarify some things, kind of bring everything together because we've been doing a lot of different activities analyzing the parabola. But I want to take a second to really appreciate and look at the quadratic equation and the quadratic functions that describe this parabola. So when we started with our parabolas and our quadratic equation, we showed that our quadratic function takes on the form y equal to some number a times x squared plus some other number b times x plus some last value c. So if you saw that leading term, the x squared, so this is our leading term, you'll see that the power of 2 really gives that away. We talked about how to factor a few weeks ago, so I'm going to just quickly go over that so we can introduce our other one. But it's good to know that this is the standard form. Standard form. We call it standard form just because we can compare it to other families like mx plus b and see that they have more or less the same type of form, but there's some other terms involved. In this case, if we were to get rid of the x squared terms, we'd have bx plus c, which defines our slope-intercept form, so adding that x squared term gives us the quadratic function. But there's other forms of it that we want to appreciate and explore because we're able to graph these parabolas. We're able to investigate where certain values lie on our coordinate plane in order to kind of pull out information without having to look at the graph every single time. So a good review is just looking at factoring. So remember, for factoring a quadratic equation, and it's just best to do this by example, we're going to actually look at our equation y equals x squared plus 5x plus 4. Last assessment, I kind of asked you guys to solve for this when it was equal to 0. And so we're going to look through and see how we can actually explain that and what it means for the graph. We'll talk about vertex form and finally completing the square. So this is going to be a little bit of a long lesson. We'll try to keep it under 20 minutes though. Okay, so we start off with our equation, and remember the first thing we want to do is gather a, b, and c. So 1, we're going to gather a, b, and c. So our a term is always going to be the value in front of our x squared. So in this case, we have that a is equal to 1. Our 5x is going to give us our next one. Remember, it's including the sign in front, so b is equal to 5. And then finally, we have our c term right here. C is equal to 4. So with these three, we can now put it into our crisscross. So place values into the cross. And so we want to do this so that our a times c is up top. And we want to multiply up to those. And then our b value is at the bottom. And we want to add to that one. So we're looking for two values. And when we do this, they'll multiply up to a times c, they'll add up to b, or they'll add up to 1 times, or multiply up to 1 times 4, add up to 5. So let's do this specific example right here. So we've got 1 times 4 up here, so I'm just going to call it a 4. And then down here we got a 5. So I want to multiply up to 4, add up to 5. And if you are not sure, you can always do some checks. I would recommend doing the multiplication first, then seeing if those two numbers add. But right now we know that 4 times 1 is 4, and it adds up to 5. And we can check that. And we know we have 4 times 1 is equal to 4. 4 plus 1, well, that's equal to 5. So we're good, okay? So from here, what we do is we're trying to turn this into some equation where y is equal to some value x plus that one of the values, and then x plus the other value. So that's step 3. Place found values into y equals x plus the first found value times x plus the second found value. So these are going to be the values that we were looking at that multiplied up to the top, added up to the bottom. So in this case, we found that we had a 4 and a 1. So it turns out that these two forms are exactly the same, and I'm going to box these to make 100% sure that we can see what we started with and what we ended with. These two expressions are the same exact values. If you put in some x's, say we put in x equals 1, if we evaluated our y, we'd get the same exact value as up here. They're equivalent expressions. If we graphed them, they'd represent the same parabola. So when we're looking up here, we see that there's not much information, not much useful information. We did know that that plus 4 can give us our y-intercept, but that's about it. But with this form, we call this factored form. We can see that, so just most general, x plus a times x plus or minus a times x minus b This is useful because it'll show us that our parabola is crosses the x-axis at A and at B. So if we have our parabola, let's make it slightly off-centered. If we're looking at it in this form, which we can do by factoring, we'll actually see that our A value gives us one of our x-intercepts, and our b value gives us the other x-intercept. And we can actually see this by example with this equation. So let's keep working through times x plus 1. And just to be complete, we'll show that, we'll even write down that these two are our two x-intercepts. So when we're checking this out, we can verify that they're x-intercepts because we know that that's the value of x when y is equal to 0. So what we're going to do is graph this equation just based off its x-intercepts. So here we have that we want to match it to this equation or show that this is actually going to give us these values. So first we want to set y equal to 0. So knowing that right on these x-intercepts our y values equal to 0 is going to be equal to x plus 4 times x plus 1. So now we're going to use the product of zeros property to know that if we have two factors multiplying to equal 0, then one of these two has to come out to 0. Or in other words, our x plus 4 should be equal to 0. So when y equals 0, x equals some value. And we also know that x plus 1 can come out to 0. Or when y is 0, our x value is going to be some value. So it's just a one-step equation. We subtract 4 off both sides and we get x is equal to -4. So when x equals -4, remember y is equal to 0. But we also have another solution where we can subtract 1 off each side over here. And we get that x could also equal -1. So when x equals -1, y is also equal to 0. So notice how if we were to follow this rule here, we'd get a very similar form. Because we have x, and we're trying to match this to this, so we have minus a -4. And then over here we have a +1, so we want to turn that negative. 2 negatives make a positive. So x minus -1. So if we were to graph these guys out, or just do a quick sketch, because what we're really interested in is where our values cross the x-axis. We'd see that our factoring by setting equal to 0 gives us an x equal to -4, 1, 2, 3, 4 when y is equal to 0. And we also have the fact that x equals -1, y equals 0. So we did that by the property of 0, the product of 0, or product of two values equaling 0. One has to be 0, or we can just look at our factored form. So our last step is to really just draw our line through it. So if we're trying to find the vertex, and this is going to be helpful for individual work, we're going to take the average of these two. We want to find the halfway point. So when we take the average, we get -4 plus -1 divided by 2, or we get -2.5. So that's the halfway point. We can see, all right, if we go -1, -2.5, we have our vertex. Notice how it's along the line of symmetry. So it's a mirror image of each side. When we graph out this thing, we'll see that it should cross the x-axis just as far on either side of our parabola. Okay, so that is the standard form, the factored form. So now we have one more to talk about, which is the vertex form. And we actually were exploring that a little bit last time. Vertex form. And in vertex form, we know that the general equation is y equals a times x minus some value h squared plus k. And so this one's actually really convenient because we can look at the vertex. So when we were graphing back here, we were interested in the x-intercepts. But here we're interested in the vertex. So what we can do here is know that the a corresponds to the width of our parabola. We saw that in the activity last time. H is the horizontal shift, how we go left and right on our x-axis. And finally, k is our vertical shift. Or in other words, how are you moving up and down on your y-axis? Or how is the parabola moving up and down? What we'll also find is that hk is going to be our vertex. So h and k. So it's pretty nice. We can actually look straight at this form and know exactly where our vertex is. So let's give a nice little graph representation of this. So if we start off 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if we have our parabola maybe sitting right here, Well, the A told us our width. How wide is this thing? Our H told us, all right, step over H steps. Our K told us to step up K steps. And so that means our vertex is hanging out right here at HK. Okay? So say, for example, we wanted to graph something like y equals 2 times x minus 3 squared plus maybe, let's say 4. So if we're looking at this, we want to collect our A, H, and K. Well, we have our A is 2, H is 3, K is 4. So when we want to graph this, it's just looking at the equation and saying, okay, how much is my vertex shifted if it starts at 0, 0, left and or right? How much is it shifting vertically? We'll see that we have to go over 3 steps, 1, 2, 3, and then up 4 steps, 1, 2, 3, 4. So that's our vertex. We know that our 2 is positive, so it's going to be opening upwards. So A is greater than 0, so it opens upwards. We saw a lot of that in that first activity. So that's why it's opening upwards. And then finally, our H and our K shows us, well, we shifted over 3 steps and we went over 4 steps to get to our vertex. And it's simple as that. We were able to sketch out this parabola, the location of it, as well as if it was upwards or downwards, just by looking at our equation. It's just by what we call inspection. So a lot of the time you will receive your quadratic equation in standard form, and you might want to do a little bit of calculations to get to vertex form. So when we do that, we are going to need the strategy of completing the square. And so that helps us in many different cases throughout algebra. Specifically for this context, though, it helps us transform standard form into vertex form. Or in other words, we're going from the ax squared plus bx plus c, which doesn't have very much useful information to think of it as a parabola, and we change it to y equals a times x minus h squared plus k. So for this case, these two a's are the same exact value. Nothing's changing. But sometimes we're not going to be able to get, we're not going to get much information out of this. So let's see how we can do this. And we're actually butting up towards, okay. So for this example, we're going to look at an equation. So we're going to take in our example, graph the equation x squared plus 4x plus 7, y equals x squared plus 4x plus 7. Okay? And actually what I'm going to do, we might want to have plenty of room. So I'm going to leave this alone, flip to the next page so we can have as much space as possible to get all this working. So graph y equals x squared plus 4x plus 7. So we could transform this into factored form. We could take our a, b, and c, we could say, all right, we need to multiply up to 7, add up to 4, but I'm not really sure if there's even any numbers. I mean, we can try 1 times 7, but that'll give us 8 if we add it up to it. We can do like -1 times 7, -7, That'll also give us 7, but that'll, again, add up to -8. So we're kind of stuck here. So what we can do instead is complete the square. And so it's a 1, 2, 3, 4 type of step. So let's start off with x squared plus 4x plus 7 on one side, and then we're going to keep our y just hanging out here. So we're really going to be changing the left side a bunch and following along with the right side, but we're really focused on changing this form into our y equals a times x minus h squared plus k form. So let's take a look at this. The first thing we're going to do is move our constant to the right side. So move that 7 or the value alone to the right side so we can have these the x squared and the 4x term together. So that's step 1. We're going to move the constant. So this is our constant. I'm even going to underline it as purple so we can see that that is our constant to the right side. Or if you have it in this case, the 7 moves to the left side. Basically, we want the x terms alone. So we do that, subtract 7 off both sides. Minus 7. These two will cancel, and we get x squared plus 4x is equal to y minus 7. So next thing we want to do is get some value, add in some value, so that we can factor this down to a squared term like we have here. X minus h squared is just saying x minus h times x minus h. So if we can get that form after factoring this, we're in good shape. So let's do that. Step 2. Find the value that will give a squared factor, such as what we have right up here. Two factors that are the same thing. So there's actually a pretty straightforward way of doing this. You take the value in front of your 4x, remember that's b, you cut it in half, and then you square that thing. Okay? And then this is the value that you're actually going to stick into your equation. So here we know our b is equal to 4. We cut that in half. So that'll give us 2. And then we square that thing. So that gives us 4. So we can put that 4 into our equation right here. Remember, whatever we add to the left side, we have to add to the right side. So we have to add 4 on this side as well. So from here, we're just going to clean it up a little bit. So we have x squared plus 4x plus 4 is equal to y minus 7 plus 4, or we have negative 3. And then we have our y hanging out right at the end. So from here, we can factor this form. So we're doing our crisscross again. Collect our a, b, and c. We know that if there's no number in front of our x squared, it's just 1. So we know that our c is equal to 4, so we're going to put it right up here. And we know our b is equal to 4 as well, so we're going to put it up there. So we're looking for a value that when we multiply it, we go up to 4, and when we add them, we get up to 4 as well. And hopefully you see that that is 2 and 2. 2 times 2 is 4. Check. 2 plus 2 equals 4. Check again. So this side can actually be turned into x plus 2 times x plus 2. And now we have a negative 3 plus y. So that was step 3. We've got to factor the side with the x's with x terms. So this is really, this is all that we need. So now we notice we have a repeating factor, so it's really just clean it up. So here we have x plus 2 squared. Repeated multiplication, we can show as squaring. The minus 3 plus y. We're going to add 3 to both sides to get our y alone. And we'll find now that y is equal, I'm just switching it around, to x plus 2 squared plus 3. So finally, for our last step, we just need to collect a, h, and k and graph. So right here, we're comparing it to y equals a times x minus h squared plus k. So we know that our a is equal to 1. Our h, well, we need to put in a value in here so that we get a positive 2. So if we plug in a negative 2 right here, notice how we have 2 negatives cancel, we get the plus 2. So h is equal to 2. And then k right here, well, that's just equal to 3. We've got it right here. So finally what we do, it's just like we did in our last example with vertex form. We just observe where we have our h's and our k's and our a's. We know that we have to go over 2 and up 3 to get the vertex, and we know that a is bigger than 1, so it's opening up like so. All right, so a little bit of a process, but remember when we're graphing this, we need to get the constant on the right side, or all our x terms alone. Then we need to find that missing value, add it to both sides. Remember, it's just taking half of this and then squaring it. In this case, it was 2 to 4. Then we factor it. Then we rearrange it to set it up in vertex form. And then from there, we just take this information so that we can graph it. Okay? All right.